Krazifizix. All right, hi there. We're quickly looking at a question that was sent on our group, and we're going to try to quickly expand on this question. This is Krazifizix. Now, in the diagram below, DGFC is a cyclic chord. Please, it's important to highlight your cyclic chord. It's going to really help you. DGFC. So if I quickly highlight my cyclic chord there, DGFC. Okay, there's a very tiny line there. It's a cyclic chord. AB is a tangent. Okay, so we have a tangent there, which is AB to the circle. Chords DB and BC are drawn. DG and GF are produced to meet all of that. And EA is parallel. Now, once I see that parallel stuff, I know that I should be thinking about fun angles. When I see a tangent, I should be thinking quickly of a tan chord. Now, the center is not mentioned here, so I'm not thinking about tan rad. Now, let's quickly answer the questions. Give a reason why B1 is D1. I'm going to go to B1 and see what I know about B1. Look at B1 there. Oh, B1 is an angle between a tangent and a chord. So if I look at that chord, let me get a highlighter. That's the chord and that's the tangent, and the chord goes to D1. So this angle is equal to that angle. And my first answer, number one, is a tan chord. Beautiful. Number two, proof that triangle ABC and ADB are parallel. Here's the skill that I want you to learn. Every time they ask you to do this, list the angles out. It's going to make it very simple for you. All right, so if I look at triangle ABC, all right, and triangle what? Let me do it here so that I want to show you. I'm doing my rough work here now. Triangle ABC and triangle ADB. Let's highlight that quickly. Running, I don't want it to be too long, so you got to follow. A, B, and C. Okay, so ABC, that's my triangle. So look at the angle. It is A1, B1, and C. Make sure you list them in order. A1, B1, and C. Now let's go to ADB quickly. ADB. So it's A, D, and B. So it's A1, D1, then the whole of B, B1 plus B2. So it's A1, D1, A1, D1. And whenever I need to prove similarity, I only need two angles. Check A1 and A1. Oh, they're already equal, common. B1, is B1 equal to D1? Yes, that is 6.1, and I'm done. Those angles must be equal. You only need to find a reason. And look at my write-up as quickly as possible. You are getting your marks. All right, angle A1 is common. Angle B1 is equal to angle D1. That has been proven. Or you can even write tan chord if you want. Therefore, angle C would therefore be equal to angle B1 plus angle B2. You write third angle. We can conclude therefore that triangle ABC is therefore similar to triangle what? ABD. What's your reason? Angle, angle, angle. We are done. This is what I wanted to quickly note. Every time you prove your similarity, please write your ratio somewhere. Okay, so we said ABC and ABD. Okay, we call it a beautiful face there. All right, if you see that lovely smile. So AB over, no, it's ADB. The order, very important. ADB. So first two, last two, first three. So we have AB over AD. Just write it somewhere. It's going to come in handy. Second one is BC over DB. And you have AC over AB. Let's keep it there. We're going to need it somewhere. Just leave it. Proof that angle E2 is equal to D2. Now let's look at E2. We've got to study the angles. E2 and D2. I actually wish I could make this a bit bigger. Let me see. E2 and D2. 1 second. I want to see if I could just make the diagram a bit bigger. Okay, there we go. I didn't have a clearer picture, so I'm just working with what I have that was sent on our Krazifizix WhatsApp group. So this is what we have. Okay, so I'm going to use this as my big diagram for visibility. Okay, I hope it's better. Now let's go. We're proving that E2 is equal to D2. Let's go look for E2, angle E2. And it's not very clear, so I'm going to assist us. That's angle E2. We want it to be equal to D2. Okay, the first thing I'm going to look at quickly, my learners, is that this is a cyclic chord. Let's make it a bit. So I see that angle D2 is in a cyclic quadrilateral, and we are told that this line is parallel to that line. Okay, so look at what I am going to do. I am going to first see what angle is D2 equal to. If this is a cyclic chord, angle D2 will be equal to that angle F1. That's F1 there. Why? Exterior angle of a cyclic chord, because that is a straight line. That line is an extended line. All right? And because these two lines are parallel now, I can simply think of alternate. Do you see? This angle is equal to that angle, and that angle is equal to that angle. So both of them are equal to F1. I'm going to write my number 3 now. We are already done there. E2 is equal to F1. Alternate what? Angles, because we are told that EA is parallel to GF. And I know that D2 angles is also equal to F1. Why? Exterior angle of what? A cyclic chord. Do you notice now that since both of them are equal to that, we can finally conclude that E2 is equal to D2. Done. Number 4. Prove that AE squared is equal to AD squared and AC squared. When I see that, I'm going to run to my ratio first to see something. Do I have these letters? Let's see. Prove that AE squared equals to AD and AC. Do I have AD? Okay, check. I have AD here. Let me mark it. So I'm going back to my ratio. That's why I said let's write it. I have AD. I have AD. Then I have what? AC. Oh, beautiful. Do you notice I have these two? Lovely. So let's work that out. So if I write AD over AB over AD is equal to what? AC over. So what do I see? I see that AD multiplied by AC is AB squared. Lovely. But the examiner wants us to prove it as what? AE squared. Let's go check something there. The examiner wants us to prove it as AE squared, but we have AB squared. So is AB equals to AE? Oh, ends deduce. I'm seeing the last one. Ah, sweet. Good. We're already almost on the last one. Okay, let me show you how to work out 6.4. I'm going to work backwards now. Please listen. The examiner says prove that A is squared. So I know that for me to get AE, I have to multiply AE by AE, right? So I'm working backwards. This is a skill. AE times AE. Oh, okay. Then I know I need to have what? AD and what? AC. If I can get this ratio, I'll get that answer. Now we are going to check something. Look at the letters on the left. What do you see? A, D, E. Is it a triangle? Let's trace it. Okay, before I trace it, I have on the right ACE. Are these two forming triangles? If they are, then we're good. We're done. ADE. AD. Oh, beautiful. I have a triangle. Then ACE. Let's check. AC. Oh, beautiful. I have another, guys. Once you see that your formation gives you two triangles, know that you are done. All I need to do is to prove that these two are similar. So to do it, you work backwards. Rewrite this AE times AE would give me AE squared, then distribute the AD and the AC. Now you are looking at a triangle. Somebody's saying, how do I know where to put AD and AC? If it doesn't work, you switch them over again. But since this is AE and AE, it would work. Sometimes it doesn't work. What you need to do is to bring this back here and take this back there and check. There should be 3 letters there. All right, and also watch out for equal lines, but we don't have them now, so we're good. Now let's go check ADE and ACE. I'm going to clean this one. ADE and ACE. I want to check if they are similar. Now this time around, we cannot write them in order because we don't know. But I'll go check. Let's list all the 3 angles that we can find in ADE. This is a skill that makes you get Euclidean very fast. ADE. ADE. What do I have? A2, D2, and E1 plus E2. It's not in order, all right? I'm just listing AD, D2, E1 plus E2. Now let's check ACE. And remember, I only need to prove 2. A, C, and E, right? A, C, E. Okay? ACE, which is A2. Oh, beautiful. That one is actually lovely. Angle C and angle what? E2. Let's compare. Do you see that these two are equal? It's A2, A2. Now, but earlier on, we had proven that angle D2 is equal to angle E2. Do you remember that question? Oh, check this. Then we're done. Now, here is my write-up. Look at my write-up. I'm going to say angle A2 is common. Now, angle D2 is equal to angle E2. That has been proven. Then we can conclude that these two definitely will be equal. Why? It's a triangle. Therefore, E1 plus E2 would be equal to what? Angle C. Third angle. We can then say triangle ADE is similar to triangle what? AEC. Angle, angle, angle. The order is important. How did I get my order right? I just follow ADE, AEC. And once I write that, I can pull out my ratio. Look at what I'm going to do. I'm going to first pull out my ratio here on the side. What will it be? AD over AE will be equal to what? DE. I'm sure everybody knows how to write that. If you don't know how to write that, please, you've got to ask someone to guide you. It's the first 2 over the first 2. What am I looking for? AE squared is equal to, oh, we are done. Do you see that? Now in my write-up, I'm only going to write that 2. Therefore, AD over AE is equal to AE over AC because of similar what? Triangles. Cross multiply, AE squared equals to AD multiplied by AC. And like I said, I have actually answered the last one. Wait. Prove that AE is equal to what? AB. What is AE? So let me move it from here. Prove that AE is equal to what? AB. Already we have what? AE squared equals to what? AD multiplied by AC. Now we would go back to from proving question, what was it? 6.2, ABC and ADB. From proving 6.2, ABC and what? ADB. We said that AB, are we looking for AD and AC, right? Okay, let me write the whole thing again. First 2 over the first 2 on the right. Last 2 over the last 2. And first and last over that. What do we need? We need these 2. Okay, so my write-up will then be AB over AD equals to AC over AB. Similar triangle. So AB squared equals to AD multiplied by what? AC. Oh, look at those 2. Therefore, AB squared is the same as AE squared. Square root of both sides. AB is equal to AE. Thank you. This is Krazifizix. Make sure you like, comment, and share. Would love to read from you. Your comment helps somebody else to see. Your sharing helps another learner to see.